Welcome everyone. My name is Remco Mokveld, as you said. I am based in Amsterdam and I work on Disney streaming services. At Disney streaming services, we do a couple of apps for Disney and also other apps. We have an NHL app, Eurosports, and a couple more. Today, however, I will be talking about single activity by example. Single activity is a pattern that Google has been pushing for in the past years, and we decided to give it a try. And today I will be going through a couple of things that I found when we started using single activity by example, and actually mostly fragment related. Like, I know it's a dangerous topic, but I really like fragments, and they are working out really well for us. Yeah, so why this talk? As I said, it works out very well for us, but when I, for example, tweeted about this, that I was going to present here, the first response was that until they fix backstack management, this is still going to be very painful. Another examples I found online was that single activity doesn't scale, and people don't get the hype, and that big projects should be split up in multiple activities, one per feature. And last, that single activity often creates spaghetti code because your code is not decoupled correctly because it's all in one activity. So yeah, the fragment backstack is an important thing and single activity, but this talk is called by example, so I have an example app that is made, and that's based off the NHL app that we have. When you open the NHL app, you first have to select a favorite team. Once you do that, you should log in. There's 3 login methods. One is with a Canadian telecom provider, you get free accounts. The other one is existing login, and there's a free trial that you can start. Here's it's very simple, a login screen. If you want to start the free trial, you have to subscribe. It uses the Play Store subscription API, and once you are subscribed, you will have to create an account. And if you did that, you'll get into a welcome flow, which tells you that you can watch all NHL games live. And once you are through that, you will get into the main screen of the app. The main screen has a button navigation, which is like a very common pattern right now. The first tab is your favorite team, the games. The second tab is a scoreboard, and if you click on any match, you will get into a match detail. Scoreboard, as I said, which lists all the teams, and a very simple settings screen which allows you to enable push notifications. All right, so now that we have that example set up and you kind of know what I'm talking about, let's start off with fragment navigation. It's a very difficult thing. Like, the APIs have existed since Honeycomb, but there are a couple of things that you need to be aware of when doing fragment navigation, which I wasn't aware of when we started it, but quickly found out that you need to know that, and I would like to share that with you so that you will find that as well. First off, let's start with what is a backstack. I am not a native English speaker, and honestly, for the longest time, I took this like a backstack as a concept, like one thing. Well, in actual proper language, it's not a real English word. The real English is 2 different words, and that's like a very important concept that at some point dropped for me. That is actually like a stack, and you can very much compare it with a stack of cards. Where in a stack of cards, only the top card is visible, which is the same with fragments. If you have a backstack, only the top fragment is visible. At the same time, like, all cards in a backstack exist, and the same is true for fragments. All fragments in the stack are actually in the created state, so they will go through onCreate, but they don't create the view and they don't go through onStart. but they are on create. Like if you navigate away from one fragment to another, it will destroy the view, but it will not call on destroy. This is a very useful concept because like a lot of the dependencies and a presenter and stuff that you have will stay around, which is actually very much like with activities, with the caveat that like activities, or the advantage in fragments is that it does destroy the view. In an activity, it will not destroy the view when it's on the backstack. And that means that you are using more memory in your backstack, whereas fragments, the view is destroyed, so you're not using that memory. It's saved in the instance state, and it will restore once you get back to it. So yeah, that's the backstack. Let's see how we build a backstack. We can have this simple code snippet. It uses, for those that are not familiar, the Kotlin extension methods. And it will actually you will not need to do the begin transaction, replace and commit. That's all being done in this inline function. Here you see like we first start with fragment A in this case, and then we add that to a container, and then we replace that with fragment B. Let's take a look at what this stack looks like. So we have fragment A. It goes through onCreate. It goes through onCreate view. At that point, on the left side, you see the current state of the fragment. So that's created. It goes through onCreate view. Next, it goes through onStart, which causes it to go into the started state. OnResume, resumed state. And next we replace that fragment with fragment B, but we keep it in the backstack. So what happens is B comes on top of A. Fragment A will go through onPause, which reverts it back to the started state. OnStop, which will take it back to the created state. OnDestroy view, which will clean up that view. And then it will stay in created, and your next screen will go through onCreate, which gets created, onCreate view, onStart, which gets it to the started state, onResume, which gets it into the resume state, and when we then press back, it will go through onPause, which gets it started, onStop, created, onDestroy view, then onDestroy does get called because it gets popped from the backstack. We are no longer caring about that fragment. And it will be completely destroyed. And that brings it to the destroyed state. And at that point, your original fragment goes through onCreate view again. So you'll get the view. In this onCreate view, the saved instance state will be filled. So you can store extra state in there. OnStart gets in the started state. OnResume gets it in a resume state. This is like the basic fragment API, but there's one thing if you want to build a backstack like this. Like in some cases, which we'll get to later, you actually want to build an artificial backstack. And in that case, if you do these two commits after each other directly, there will be a lot of unnecessary view creation, because your whole fragment A will create a view, and that will directly be destroyed again. For this, a very important API in the fragment transaction is actually set reordering allowed. The documentation on that says that there are a couple of caveats on using that, but I saw that Ian Lake, one of the developer advocates at Google, actually said that you should almost always use this. And that looks like this. We have to set reordering allowed, set it to true. And next, let's look at all the state changes that are going to happen. I don't know if everyone can see it, but on the left you see the first transaction that happens. It's the black boxes are fragment A and the white boxes are fragment B. And if you have set reordering allowed, these two transactions will actually, because you don't commit now but you use commit, they will be executed directly after each other. And by set reordering allowed, it will look at which events actually cancel each other out. So on resume and on pause from the fragment A cancel each other out, so they will be removed. On start and on stop will cancel each other out, so they will be removed. On create view and on destroy view will cancel each other out, so they will be removed. So if you use this, it will actually, fragment A will go through on create and then stop, and fragment B will then directly start, and this way you can like completely do your custom backstack building, which will come in very handy later. We can very quickly go through those states. So this is created on create, and then the second one gets created on create, on start, on resume, on stop, on destroy view, on destroy, and then if you press back, then your first screen will go through on view created and on start for the first time. That's like the first important method on the fragment transaction that I want to discuss, and the second one is the primary navigation fragment. This is also something that's being used very much in, for example, the navigation components API. And it's actually like the primary navigation fragment, that's one of the main drivers for like having a the concept of an activity being replaced by the concept of a fragment. So everything you can do in an activity, you can also do in a fragment that is the primary navigation fragment. Primary navigation fragment is a property on the fragment manager. So every fragment manager has one primary navigation fragment at any time. So if you replace that screen, it will change the primary navigation fragment. If you pop the backstack, it will revert to the primary navigation fragment. This is currently what the app looks like. We have an activity, we have a splash screen onboarding fragment. The onboarding fragment hosts 3 other fragments, and you have the main app fragment, which also hosts 3 other fragments. So when we start the app, splash is the primary navigation fragment of the main activity. And when we finish splash, onboarding starts, and onboarding is the primary navigation fragment of the activity, and favorite team selection is the primary navigation fragment of that onboarding fragment. You can walk through the entire app and there's like always one primary navigation fragment. Why we need this is that it's required for nested backstacks. Because backstack, the pressing the back button should only be handled at one place at a time. You don't want 2 fragment managers to both pop a state if the user presses back once. So the handling of the backstack should always happen depth first, which means like your activity can first your activity will first check if its primary navigation fragment can handle it. If that fragment has a primary navigation fragment, it will check that, and if that doesn't handle it, then you can go back up. So it's like a depth first algorithm. In the sample app, we have a very simple interface called back handling fragment. If a fragment is interested in handling back buttons, it should implement that. And next, in the main activity on back pressed, we call a method called handle back press depth first. It's a very long method. You should probably name it shorter. But for demonstration purposes, it has that name right now, and it will call that with its primary navigation fragment. If that primary navigation fragment is null, it means that the fragments don't handle it, and it will just return false, and then it will call super on backpress in activity. If there is a primary navigation fragment, it will first check that child manager primary navigation fragment, and if that can handle it, or if that has, like, there is a recursive call, what you see at the top line that's highlighted now, at line 10, it will call the handle backpress depth first on that child fragment, so that in that way you go depth first, and you make sure that one fragment in the primary navigations line handles it. If no fragments exist that handle it, it will just return false, and super on backpress will be handled, which in the standard case will actually just pop the backstack. But as of yesterday, this was outdated. We had a speakers dinner yesterday, and then when I checked back, Ian Lake mentioned on Twitter that the new alpha release of Android X got released, and they have a new API for handling backpress, and that actually it's called on backpress dispatcher. It's a lot easier API. I did update the slides to have this, but I didn't get the time to actually discuss it. But I would definitely recommend checking that out if you are interested in custom back behavior. So yeah, that's the two important functions on the fragment transaction that I wanted to talk about. And next is actually in the sample app, we only have two functions defined for fragment navigation. We don't do any. Well, in those two functions, we do fragment transactions, but otherwise we don't do any other fragment transactions. I would really recommend everyone to do the same if you start with fragments. And like the fragment transaction API is very complicated and very flexible, but in the end, you most of the time only want to have like few basic behaviors. The first fragment we have is just add to backstack. You pass in a container. It's an extension method on the fragment manager. You pass in a fragment and possibly a backstack name, and it will just do a begin transactions, replace, add to backstack, set reordering allowed, and set primary navigation method, set primary navigation fragment, and that's all it does. And the second method actually uses that first method as well, and that says replace the backstack. What this does is it first pops the backstack completely, and then it will take the root fragment and it will add that without backstack, without add to backstack, and then it will go through a list of stack entries, which is a combination of a fragment and a tag. And it will add all of those to the stack. So like in that case, you can build your complete backstack and have all those fragments go through on create only, and only your last one will actually be completely visible. If this is a bit confusing, don't worry, I'm gonna share the link to the projects later, which where you can look at all the codes in peace. But yeah, those are the only two navigation functions that we have, and that concludes the backstack the fragment navigation part of the talk. Next is the scalability. That was a concern, and I'm gonna put out a bunch of statements now, which we'll get to later, like why I think those are true. In a single activity, the activity is your single entry point of each app. So you only have one activity that gets launched. Fragments can be a single entry point for each feature. So you can build every feature in a fragment. The advantage of this is that your activity actually presents a complete user session. So you can, if you want to have like foreground, background, or for example, for analytics, want to track foreground, background behavior, your on start of your activity is when it goes to the foreground, your on stop is when it goes to the background. You don't have to worry about multiple activities. There is a process lifecycle observer, which I'm not going to talk about right now, but it's much easier if you're a single activity, because it's just those two events. And then fragments can represent either individual screens or flows. In our example, the onboarding fragment represents a flow, because it will start screens below it. Like we are nesting fragments very heavily. We in a production app that we go like 4 or 5 layers deep in nested fragments, and that works out very well. Yeah, so that's the scalability part. I think like you can almost build an entire app in a single fragment, and there's actually an example in our onboarding in the onboarding app where it is an entire app. So let's take a look. The onboarding flow has a quite peculiar back behavior, because it starts with a follow team fragment. Next, you open that paywall screen, you select subscribe, and at that point, once you're subscribed, you actually don't want the user to go back to choose one of those other login methods. So it went quite quick there, but it's actually like once the user is subscribed, we want to replace our backstack. We still want them to be able to choose another favorite team, but we don't want them to choose between the login methods anymore because they've already chosen that. We can take a quick look at that again. No. But yeah, so the onboarding flow, it has a lot of different screens. It's quite a complex back logic, as I said. And like according to those original statements in the beginning, that would warrant an onboarding activity. But the onboarding activity is actually quite tough because you don't know what's coming next. Like once you're done with onboarding, especially if you are a feature module-based app, like providing the navigation to the next screen will then require you to do some weird dependency injection. And whereas actually like we can have that completely in a fragment, and the only thing we care about is whether onboarding is done. The structure looks approximately like this. So you have an onboarding fragment which hosts up to 5 different screens. And to use this in the app, we actually like only need to use that replace stack method with just the onboarding screen. Because we use replace stack, it will be the entire backstack will be popped. So pressing back will exit, and you build up a backstack within that onboarding fragment. And second, we have that interface, or we have an interface called onboarding host, and we make sure that the activity implements that onboarding host. And so we then at some point need to call that once the onboarding is done. For this, I've seen a lot of cases where, and I did it myself in the past as well, quite often, where you then on attach of the fragment you cast the activity to that interface. This works sometimes, but especially once you go do that deeper navigation, it might not be the activity that implements it. It might be a parent fragment that implements it. So therefore, there is a function that we call find parent that implements, and you specify the type that you are looking for. This is an inline function, which actually with a reified type parameter, so it can actually get that class instance. Yeah, that's the onboarding host fragment, and then we can use that to find the interface. For this is the function I was talking about. What it does is it checks if the parent fragment of the current fragment implements that interface. If it does, it returns it. Next, it checks if there is a parent fragment. If there is a parent fragment, we want to find that interface in its parents. So it's again a recursive call. If that's not the case, we'll check if the activity implements the interface, which was in our case the scenario. If it does, we'll return the activity, and the last option is if the application implements that interface, we'll return the application type, and if all else fails, crashes. This is actually, for those that are familiar with Dagger Android, this is exactly the same mechanism that Dagger Android uses to find parents that can provide a subcomponent to inject its dependencies. And it's a very powerful method of a surface locator pattern, which means that now the fragments can be used everywhere as long as one of its hosts implements that interface. But what about that custom back behavior? If you remember correctly, we had a backstack of 4, so the follow team fragments, paywall, subscription, and then the sign up. What we can actually do, instead of starting that sign up by adding to the stack, we can call the replace stack function, and we can go look in our fragment manager and find that follow team fragment. We start it with a tag, and if that doesn't exist, we'll just create a new one. but we can have that as the first entry or the bottom entry of the stack. And if it is actually in the fragment manager, it's already in the created state. So you can build the entire backstack and it will never actually get any lifecycle events because it's already created, it's already there. We're fine. It will just like remove those intermediate things from the backstack and add the new sign up fragment. So that's a very powerful way to like manipulate your backstack, and you have full control over your own backstack. It is sometimes a bit tricky because you don't exactly know when transactions are being executed, but so far we are not experiencing any problems with it. Next up is that bottom navigation. The bottom navigation in the sample app is implemented almost according to the Material.io spec. It's a very difficult spec. Like and it seems to have changed quite a bit over the past year. But this is actually the most recent behavior. First of all, you build a backstack within each tab. So if you are in a tab and you click on something, it will launch that match detail, and when you press back, it will go back. It goes a bit too fast to properly see, but let's go to the next requirement. I think you get the switching tab should reset the backstack. That's one of the requirements that they have. So if you are in the first tab, you go to the detail screen, you go to the second tab and you press the first tab again, then it should go back to the original state of that first tab. And that's what you see here. So we go into the detail, then we go to scoreboards, and then you see that item going back, and once you press home, it will replace the entire backstack, because the next requirement is that or actually how navigation components implements it as well, is that back on the first tab closes the app. Yeah, it's not a very exciting movie, but it's just pressing back and it will close the app. But pressing back on the second or third tab will actually take you back to the first tab. This is not in the spec, but it is how the navigation components implements it, and we have found that it's the one that makes most sense, because otherwise you might unexpectedly get people to get out of the tab. And the last one is that pressing the tab item while on the top level content will reset the tab to its original state. You see here, scroll down, press back, or press home, and it will scroll up. And actually, the implementation for this, when using that when using that replace stack fragment, is actually very easy, because we can again replace the stack. Like for the second and third tab, we can replace the stack with what's currently the my team fragment or a new my team fragment, and add that new fragment, which is either sign up settings or scoreboards, as the backstack entry. And then because it's for the same reasons, it will actually not touch that my team fragment to begin with. But when you press back, you will actually go back to that next team fragment. I see I'm running out of time, but I just quickly want to handle the next bit, and that's startup checks. We have quite a few apps where we need to do startup checks, which needs to be done on every startup. Examples are to prefetch data, or checking if a subscription has lapsed, or fetching an AB config. In the past, I've very often used in a multi-activity window thing, I've used a splash activity. I searched GitHub public repositories on the word term splash activity, and there's 104K results in Java code. That does not include Kotlin code, which all have splash activity. So apparently I wasn't the only one. But there's a couple of problems with having a splash activity. First off, if you are past that splash activity and you background the app forget about it. The user comes back 3 days later, but it's still like he doesn't use his phone very often, so it's still in the recents. If you press on the recents, it will actually go back to the last activity that it was on, so it will never go through splash activity. Another thing that's very often is like, if the checks need to be done, we want to show the splash activity. But if they don't, if everything is okay, we don't want to show it. We want the user to go back to the app as soon as possible. When you have a splash activity and it's like the launcher, it has the launcher intent filter, and you press the launcher, then we'll always go through splash and start a new main activity, or whatever your activity is called. Which will always do that check. When you're single activity on the other end, you can use your onCreate function. Because whenever you go back from the backstack or anything, like in onCreate, your single activity will always go through onCreate. And in our example, we have an onCreate function here. It will set the content view, then it will check if the saved instance state equals null. So if it isn't, like, that's a very important one on fragments actually. If the saved instance state is not null, you almost never want to do a fragment transaction in your onCreate, because the fragment manager handles its own state, and if you do a fragment transaction, you then replace that original fragment with which is going to be restored with a completely fresh one which doesn't have any state. But so yeah, we check if saved instance state is null, and then we have a count repository which is scoped singleton, which just keeps a reference to your current account, and if that is available, we can just start the app directly. We don't need to go through, or if that's not available, we'll go through Splash. And if it is available, we'll just start the app directly. The user will never see a Splash fragment, and that's like, it makes the experience so much better if you don't go through that splash. Like, I'm sure you have seen it as well, where a timer is being set to show the splash, and then it's after 2 seconds it launches the main activity. And if you background the app before that, it will actually still launch the main activity because the timer is never cancelled. If you have this, then you don't need to worry about that at all. That was it for most of the content. I now still have some key takeaways and tips, and that's that nested fragments are good. They are a good thing. Like, if you are single activity, like nesting it is very good. Like, it allows you to do a lot of backstack behavior, which is very nice. And every UI feature can be built in a fragment. Actually, in our case, in a sample app, the onboarding fragment uses Dagger Android, but it uses a slightly custom Dagger fragment, which means that it has its own Dagger component, and it doesn't actually need to be a subcomponent of your parent. So it's like completely separate. You can plug and play it into any app. It uses full Dagger, but it's not. And yeah, it's really just starting the view. Generally, if a feature becomes too big for a fragment, you'll split it up into child fragments, and that's where that nesting comes in. Fragments should never depend on their host. Instead, fragments should depend on their host implementing an interface that they define. Always use the primary navigation fragment. If you're doing fragment navigation, like there are some headless fragments and stuff where you don't want to use the primary navigation fragment, but for everything else, you should. Always use set reordering allowed. And yeah, what I say, single activity and this fragment stack gives you full control over your backstack, and that's very handy. And finally, some caveats related to fragments. What I said, only do initial navigation when saved instance state is null. A very important one is don't mix up fragment managers. A fragment has a fragment manager and a child fragment manager. The fragment manager is actually the child fragment manager of its parent, or the fragment manager of the activity. And the child fragment manager is owned by that fragment itself. Basically, you almost never want to navigate on your parent's fragment manager. You just want to have that callback to say, like, hey, I'm done. Do the next thing, and then it's up to that parent to control its child fragment manager. And a last one, which I really wanted to get out, but I didn't get the time to actually talk a lot about it, is that for navigation screens, either always use add to backstack or never. Oh yeah, like either always add to backstack or replace the entire backstack. That's it. So like you don't want to have some primary navigation fragments being added to the backstack and others where you don't have that add to backstack, because that gets really messy. And if you have A, or if you first add fragment A, then you add fragment B, which you add to the backstack, and then you add fragment C, which you don't add to the backstack. If you then press back, it will actually never remove fragment C because it doesn't know about fragment C. It will remove the content from fragment B, which was already removed, and you'll get fragment A. And I think that's something that I saw a lot before I knew about this, where you see like two fragments, or the views of two fragments in the same container. It's a bug that probably everyone that worked with fragments has seen at some point, but it's very hard to track. And the very last thing is that, unfortunately, transition support in fragments, it's painful. I know it's on the short list for Google to fix on fragments. Like, fragments were bad in the beginning. They fixed a lot of stuff, but this is something that they didn't fix yet, and I have full confidence that they'll fix it soon, but hopefully at I/O this year. I don't know, but yeah, that's it. And then finally, this is a link for the sample project. It's a fully modular project. It has some instrumentation tests. It has like the whole fragment navigation. I'd recommend you to check it out. And that's it.